Alright guys, welcome back. So like what I said before, so in this chapter we must know how to do calculation for a solution. So if we are given solution, if we are given liquid, we must know how to do calculation. Okay, so there are total 3 formula that we learn. Okay, so the first formula is called N equal to mv over 1000. So this formula can be used to calculate the mole for a solution. So for example, today you are given a solution. Let's say an acid lah. Okay, acid is a solution. Okay, so let's say you are given an acid and you want to find the mole of acid. So you can use this formula to calculate. So the second formula is M1V1 equal to M2V2. Okay, so this is the formula that we use. Okay, if we want to do calculation that is related to dilution. Okay, all right. So if today we have a dilution question, so we can use M1V1 equal to M2V2 to do the calculation. So in today's lesson, we will learn the last formula, which is MAVA divided by MBVB equivalent to A divided by B. Okay, so this formula can be used to calculate something that is related to neutralization. Okay, so neutralization is a very important subtopic that everyone must know, everyone must understand about this. Okay, neutralization idea. Okay, so we need to learn 2 parts for this neutralization. Okay, so in today's lesson we will learn the concept of neutralization and we will learn how to do the calculation for neutralization. Okay, so there are total 2 things that we will learn today. So first of all, we need to learn the concept for neutralization. We need to learn the concept of neutralization. So what is neutralization? Okay, what is the meaning of neutralization? So neutralization is a chemical reaction. Neutralization is a chemical reaction between an acid and a base. So we take acid and base to mix together so that they can produce salt and water only. Okay, so for neutralization, the final product must be salt and water. Okay, so that's it. Okay, so I repeat one more time. Neutralization is a chemical reaction. So to get neutralization reaction, we need acid to react with base. When we take acid to react with base, so this is a neutralization process. Okay, and neutralization process, the final product is salt and water only. So we will only get salt and water, nothing else. Okay, only salt and water, no more other things. Okay, all right, so that is neutralization. Okay, so let's do a quick revision. Okay, so what do we mean by bases? Okay, what do we mean by bases? Okay, so we learned in the earlier part. Okay, base is referred to metal oxides and metal hydroxide. So if you have any metal ended with O, any metal ended with OH, they are bases. Okay, example MgO. Magnesium is a metal, so when the metal ended with O, this is a base. Sodium hydroxide, sodium is a metal, when the metal ended with OH, so this is a base. So any metal that actually ends with O or OH, so we can call them as base. Okay, and we also learned before, if the base is actually soluble in water, so if you have a base and it is soluble in water, we can also call it as alkali. We can also call it as alkali. Example, okay, potassium hydroxide is a metal and end with OH, so it is a base. Okay, so potassium hydroxide is soluble in water. So when potassium hydroxide is soluble in water, we can also call it as alkali. Okay, so we learned this concept previously. Yeah, we learned this concept previously. I hope everyone able to see the difference between base and alkali. Yeah, because there are so many students, they always mess up the base and the alkali. Okay, all right. So that's it. Okay, so when acid react with base and you produce salt and water, so this is called neutralization reaction. Okay, so let's do a quick check lah. Okay, let's do a very quick test together. Okay, all right. So now you are given 4 chemical reaction. Okay, acid plus metal to produce salt and hydrogen, acid plus base to produce salt and water, acid react with carbonate to produce salt, water and carbon dioxide, acid react with alkali to produce salt and water. Okay, so now we need to decide these 4 chemical reaction. Okay, so we need to decide, is it a neutralization reaction? Okay, is it a neutralization reaction? Okay, so how to know whether the reaction is neutralization or not? Okay, so let me give you a tips. Okay, so if you want to know the reaction is neutralization or not, you just need to check 2 things. The first one, you must have acid in the first place. You must have acid, and the final product must be salt and water only. Okay, nothing else. Okay, so that is neutralization. Okay, let me show you. So the first reaction, do you have acid? Yes. So the final product, you must have salt and water. So do you have water here? Don't have. So you only have salt, you don't have water. So this is not a neutralization. Neutralization, the final product must be salt and water only. Yeah. So that's why from here I know already the first reaction, it is not a neutralization reaction. Okay, so let's try another one. So the second one, when acid react with base, we get salt and water. So how to know this is a neutralization or not? First thing, we need to check, do you have acid on the left? Yes. So on the right hand side, the product, right hand side is the product. Do you have salt? Yes. Do you have water? Yes. Okay, so if you have acid on the left, salt and water on the right, then it is neutralization. Okay. Okay, another one. When acid react with carbonate, you produce salt, water and carbon dioxide. So do you have acid on the left? Yes. Do you have salt on the right? Yes. Do you have water on the right? Yes. Is this a neutralization? No. Why? Why this is not a neutralization? Because neutralization, the final product must be salt and water only. So we only want salt and water, nothing else. So in this question, we have salt, we have water, but we also have carbon dioxide. So we don't want that. Yeah. Neutralization, we only want the salt, we only want the water, but we don't want the carbon dioxide. So if you have something extra than the salt and water, this is not a neutralization reaction. Okay, so the last one, when acid react with alkali, you produce salt and water. So is this a neutralization? I would say yes. Okay, why? We have acid on the left and the final product is salt and water. Okay, so that's it. So I hope now everyone know already how to know the reaction. It is a neutralization reaction. Okay, you just need to make sure that you have acid, and you just need to make sure the final product is salt and water and nothing else. Okay, we only want salt and water, no other things. All right. So the next thing that you need to learn is that we need to know the ionic equation for the neutralization reaction between an acid and alkali. So if you take acid react with alkali, it is a neutralization, right? Because you see, when acid react with alkali, you produce salt and water. So it is a neutralization. Okay, So now we need to know how to get the ionic equation, okay, for the neutralization reaction between acid and alkali. Okay, so first of all, you need to understand what is ionic equation. So ionic equation is something new for you if you are in form 4. If you are in form 4, this should be the first time you learn about ionic equation. Yeah, so ionic equation is the equation that show us the ion, okay, that are taking part in the chemical reaction. Okay, so if that equation you can see ions, so it's called ionic equation. That's why you see the name ionic, A-I-O-N, ion. Ionic equation show you ion. Okay, so what do we mean by ion? Ion means charge. Ion means charge. Okay, we learned this in your form 4 chapter 2. So very simple, if the equation show you the charge, then it is ionic equation. I repeat, if the chemical equation show you the charge, then it is ionic equation. Okay, so let me show you this example. Okay, so here, this equation, do you see any charge here? Do you see any charge in the equation? No, right? We didn't see any charge at all. So we don't see any ion. Okay, we don't see any charge in this equation. So if you don't see anything, sorry, when you don't see any charge in the equation, this is chemical equation. Okay, what about ionic equation? Ionic equation must show us ion. Ion means charge. Can you see the charge? Yes. Can you see the charge? Yes. So when you see ion in the equation, then it is ionic equation. So in ionic equation, you must able to see the charge. Okay, you must able to see the charge. Okay, some people will say, sir, this one have charge, this one have charge, this one don't have charge. Okay, is it ionic equation? Yes. So as long as you see one of the charge, if you see minimum one ion, that is already ionic equation. When you see minimum, okay, one ion, that is already the ionic equation. So you can see here, all right, so here we have one ion, here we have one. So in this question, we already have two ions. So it is ionic equation. Okay, so ionic equation, you don't need to let everyone to have charge. No need one. Okay, as long as you have one of them in a charge form, okay, as long as one of them, they are ion, they have charge, it's already ionic equation. Okay, so let's make a quick summary again. So if you given an equation, in the equation you don't see any charge at all, okay, like this one. Okay, you don't see any charge, no charge, no charge, react, you form no charge and no charge. If the whole equation you don't see any charge at all, or maybe I put in some better symbol. Okay, A plus B becomes C plus D. Okay, if this equation you don't see any charge at all, this is chemical equation. If this equation you see the charge, example A plus, okay, if you see this equation got charge, it's ionic equation. Okay, so no matter you have one substance has charge, or two substance has charge, or three substance have charge, or even four substances have charge, as long as you have charge in the equation, that is already ionic equation. Okay, so that's it. Okay, so now I hope everyone know what do we mean by ionic equation. Okay, so the ionic equation for acid and alkali is this. Okay, why we get this equation? Actually very easy to understand only. Okay, it's very easy to understand why the ionic equation is this one. Okay, so the idea very simple. Okay, acid. Okay, we learn in your Form 4 chapter 6 lesson number 1. We learn in lesson number 1. Okay, acid always able to ionize in water to produce H plus ion. Okay, we learned that before, right? Acid always cut by water to form H plus ion. What about alkali? alkali also can cut by water to produce OH minus. Okay, alkali also can ionize in water and it produce OH minus. Okay, so we learned this in your lesson number 3. Okay, so you see, very simple. Okay, so when acid react with alkali, what is the ion for acid? H plus, right? Okay, think about acid, think H plus. What is the ion for alkali? OH minus. So when H plus react with OH minus, let's do mathematics. Okay, positive and negative cancel. H and H, H2. One oxygen, one oxygen. Okay, that's why the final product is water. That's why the final product is water. Okay, so the H plus ion from the acid will react with OH minus ion from the alkali to produce water. So we know water is neutral, right? Okay, everyone should know water is neutral. Okay, so since you produce water which is neutral, that's why this reaction is called neutralization. Okay, because we produce the neutral water. Okay, so I hope everyone can know this. Okay, so next time whenever the question asks you to write, okay, the Ionic equation, okay, for the reactions between acid and alkali, so this is the one. So some student will say, sir, you see, here we have two neutralization reaction. One is acid react with alkali to produce salt and water. Another one is acid react with base to produce salt and water. Do we need to know how to write Ionic equation for this? Do we need to know how to write Ionic equation for the reactions between acid and base? The answer is no need. For SPM syllabus, the Ionic equation, we just focus on acid and alkali. Okay, for SPM, the Ionic equation, we just need to focus on acid and alkali. That is what you need to know. Okay, so that's it. All right, so now I already show you what is the Ionic equation for the neutralization reaction between acid and alkali. Okay, so don't memorize, just use common sense. Acid, H plus, alkali, OH minus. So when they add together, they become neutral, water. Water is neutral. Okay, just use a common sense. You don't need to memorize. Okay, so the next thing I will show you step by step how to get the Ionic equation. I'll show you step by step how to get the Ionic equation between acid and alkali. You will learn this thing in very detail. Okay, you will learn this thing in detail in your Form 5 Chapter 1. In Form 5 Chapter 1, we will learn it in a very detailed way. For now, we just need to know the simple concept. Yeah, in Form 4, we don't need to learn so deep. We just need to know the basic concept. Okay, so now I will show you how to get the Ionic equation for the reaction between acid and alkali step by step. Okay, so how to do that? Okay, so let me show you. So step number 1, okay, we need to write a chemical equation and we need to balance the chemical equation. Yeah, so we start with writing a chemical equation and balance it. Okay, so after that we need to list out all the ions on the left hand side and the right hand side of the chemical equation. So we need to list out all the charge on the left hand side and the right hand side of the chemical equation. So then the last thing, we need to cancel out the spectator ion. Cancel out means we need to cut away. We can cut away the spectator ion. Okay, what do we mean by spectator ion? Spectator ion is actually referred to the ion that do not change in the reaction. Okay, any ion that do not change in the reaction is called spectator ion. Okay, example, on the left hand side, the A is A plus. on the right hand side, A become A plus. So this is ion, this is ion, but you can see the charge never change. So they are spectator ion, so you can cut them out. You can cut them out, okay? So if let's say this is A plus and this one become A2 plus, can you cut it? No, because this is not spectator ion, because you can see some changes. This one the charge is positive 1. This one the charge is positive 2. So the charge actually change. When there is any change, you cannot cut. So you see, if you got any change, so you cannot cut away. If there is no change, then you can cut it away. Okay, so you might feel a little bit confusing now, which is normal. Okay, so the best way is that I will show you using example. Okay, I'll show you using example. So I will use 2 examples to show you. Okay, I will use 2 examples to show you how to get the ionic equation. Okay, so let's say look at the first example. So let's do the first example together. So we are given hydrochloric acid and sodium hydroxide. Okay, hydrochloric acid is an acid, you should know it. Sodium hydroxide is one of the alkali. So we have an acid and we have an alkali. So how to do it? Step number 1, write the chemical equation and balance it. So let us write the chemical equation between the acid and the alkali. So you see, this is hydrochloric acid, this is sodium hydroxide. So we know when acid react with alkali, the final product should be salt and water. Okay, when acid react with alkali, we will get salt and water. Okay, all right. So now we already get a balanced chemical equation. Okay, so after we get a balanced chemical equation, what is step number 2? Now we need to list out all the ion on the left hand side and the right hand side of the equation. Okay, so let's try to do it together. So hydrochloric acid, what is the ion? Okay, so if you want to get ionic equation, we need to list out all the ion. Ion means what? Ion means charge. Okay, we need to list out all the charge. Okay, so hydrochloric acid, what is the charge that we know? We know hydrochloric acid can cut to form H plus and Cl minus, right? Okay, we know hydrochloric acid, we can ionize, we can cut it, and we will get H plus and Cl minus. So you can see the H will get H plus, the Cl will get Cl minus. Okay, so that is what we do. Okay, so I repeat that. Hydrochloric acid, we can cut to get H plus and Cl minus. Okay, all right. So this is the first thing. What about sodium hydroxide? Sodium hydroxide is an alkali. So we know alkali can cut also. So after we cut the alkali, the sodium here, we will get Na plus, right? Okay, we know the charge for sodium is Na plus. We know the charge for OH is OH minus. Okay, so that's what we do. So NaOH, when we cut it, we will get Na plus and OH minus. Okay, so all the ion, we put a plus in the middle. Okay, all the ion, so means that what? We have H plus ion and Cl minus ion and Na plus ion and OH minus ion. Okay, so that's it. So we put a plus, so we know that we have all these ion. Okay, all right. So after we list out all the ion on the left hand side, now we do the same thing on the right hand side. Okay, let's go to the right hand side and we do the same thing. So on the right hand side, we have sodium chloride. So what is the charge for sodium chloride? We know sodium, the charge is Na plus. We know Cl, the charge is Cl minus. Okay, so we know the charge already for NaCl. Okay, the last thing is water. Okay, water is very special. Water don't have any charge. Water don't have any charge because water is a molecule. Water is a molecule. Okay, we learned before, when non-metal combine with non-metal, they form molecule. Okay, they form molecule. Molecule don't have charge. Okay, so water don't have any charge. So we just copy. This water don't have charge. We copied it here. Okay, so that's it. So now we already list out the charge. Okay, we already list out the charge on the left hand side and the right hand side of the equation. Okay, so what is the last thing? So the last thing, we can cancel out the spectator ion. So let's do it. So again, what is spectator ion? Any ion that do not change. So let's look at this equation. So in this equation, who is the spectator ion? Okay, any ion that do not change in this case. If you look at this equation, who don't have change? Okay, Cl minus, okay, and Na plus. Can you see they are the same, right? You have Cl minus on the left, you have Cl minus on the right, so they don't have any change. We cut it. So Na plus on the left, Na plus on the right, so they are the same thing. They don't have any changes, so they are spectator ion. We cut it. Okay, all right. So can we cut the H plus? No, because H plus on the left hand side got charge, on the right hand side don't have charge. So you can see they are changes. From left hand side to right hand side, you can see this one got charge, this one don't have charge. So there are changes, so you cannot cut it. So same thing, the OH minus, you have charge on the left, but on the right hand side don't have charge, so you cannot cut. You only can cut the ion that the charge is the same on the left and right. So Cl minus, they are the same thing, cut it. Na plus, they are the same thing, cut it. Okay, so some student will ask, sir, if this is Na plus and this is Na, can we cut it? Cannot, because they are different, right? This is Na plus, this is Na, so they are different, so you cannot cut. Okay, you only can cut the same charge. Okay, so after you cut, you get the final answer already. You see the final answer, H plus react with OH minus, you get water. Okay, so the final answer, we copied it, H plus OH minus and water. So you will still get this. Okay, this is exactly what we learned just now, right? This is exactly what we learned just now. Okay, the ionic equation for the neutralization process. Okay, so let's do another one more example together. Okay, let's try another one more example together. Okay, what if now we have sulfuric acid to react with potassium hydroxide? Okay, so now we have sulfuric acid react with potassium hydroxide. So this is the chemical equation. So I hope everyone know how to write this chemical equation. If you don't know, please do a revision. Please revise back your lesson number 2. Please revise back lesson number 2. Everyone must know how to write a balanced chemical equation for the reactions between acid and alkali. Okay, acid and alkali, you need to know how to write a balanced chemical equation for them. Okay, so let me show you. This is sulfuric acid, H2SO4. This is potassium hydroxide, KOH. When acid react with alkali, you will produce salt and water. Okay, all right, so I hope you still remember how to predict the salt. I mentioned before, if possible, don't memorize the salt. Okay, you need to know step by step how to predict the formula of the salt. Okay, and make sure this chemical equation, you must make it balanced. You must always make it balanced. So we put a 2 here to make the equation balanced. Okay, so now we already have the balanced chemical equation. So this is step 1. So step 1, we need to write a balanced chemical equation. So step 2, we need to list out the ion. So let's do it. So let us list out all the ion now. Okay, so what are the ion? Okay, so H2SO4, what are the ion? So we know sulfuric acid, okay, is an acid. Acid, we can cut it. After we cut, the H will become H plus, the SO4 become SO4 2 minus, isn't it? Okay, but how many H we have here? So we have 2H. Okay, so 2H, so you will produce 2H plus, isn't it? Okay, because when you have HCl, you cut it, you only produce 1H plus. When you have HNO3, nitric acid, you cut it, you produce 1H plus. But we know sulfuric acid is a diprotic acid. When we cut it, so here you will get H plus and H plus. So they are total 2H plus here, because that's why H2SO4. We have 2 hydrogen. When we cut it, we get 2H plus. Okay, so this is very important. Okay, so H2SO4, when we cut it, so we will get 2H plus, and we will get SO4 2 minus. Okay, we will get SO4 2 minus. Okay, so some student will say, okay, why the 2 you must put in front? Because if the H2 you put plus here, this is wrong. We never learn H2 plus like this, right? We only learn H2 without the charge, or we only learn H plus. Okay, so there is no such thing called H2 plus. So we need to put the 2 in front here, so to tell people that sulfuric acid is a diprotic acid. Sulfuric acid produce 2H plus ion. Okay, so this is something that you have to be very careful. Okay, you have to be very careful, because some student, they make a mistake, they write H2 here and H plus they put here. So this is wrong. Okay, so now we already get the charge for the hydrogen. So what about SO4? SO4, the charge is 2 minus. Okay, so now we already get the charge for the sulfuric acid. Okay, so now, okay, let me clean this first. Okay, so the next thing, we will do the same. So the next thing now, we will go to get the charge for the alkali. So the alkali, we have 2 potassium hydroxide. Okay, so what is the charge? So we know KOH, when you cut it, the charge K is K plus, the OH is OH minus, right? But don't forget, in this formula, we have a 2 in front here. So when you have a 2 in front here, means what? You have 2 K plus, and you also have 2 OH minus. Okay, you have 2 K plus, and you also have 2 OH minus. So that's why you see here I write 2K plus and 2 OH minus. Okay, so I hope everyone can see why. Because the K is K plus, which you have 2 of it. The OH is OH minus, which you also have 2 of it. Okay, that's it. So now we list out all the charge on the left hand side already. So let's do the same thing on the right hand side. Okay, so let's do the same thing on the right hand side. So on the right hand side, we have K2SO4. So K2SO4, what is the charge again? So K, the charge is K plus, right? K is K plus. How many K plus we have? We have 2 of it. Okay, we have 2 of it. So that's why we must tell people the K plus ion, we have 2 of it. You have to put the 2 in front. You have to put the 2 in front, so people know that you have 2 K plus ion. Okay, all right. So the next thing is SO4. So SO4, the charge is SO4 2 minus. Okay, so lastly, we have 2 water. So water, it is a molecule. Water don't have charge, so we just copy the 2 water. We just copied it. We don't need to list out the charge, because water don't have charge. Okay, so now the whole thing, we get it already. So after we get the whole thing, so the next thing is we need to check spectator ion, and we need to find out spectator ion. Okay, so any ion that do not change in the chemical reaction, they are spectator ion, and we can cut out the spectator ion. So let's do it. So here is SO4 2 minus, here also SO4 2 minus, so we can cut it. This one is 2K plus, this one is 2K plus, they are the same thing, cut it. So after we cut, so now we left 2H plus, we left 2OH minus, and we left 2 water. So this one I copy again, so to get this equation. Okay, so this is the equation that I am getting. Okay, so but we are not done yet. Okay, because you need to know that ionic equation must be simplified. all the ionic equation you must simplify. Okay, simplify. So let's look at it. This number is 2, this number is 2, this number is 2. So you can simplify all the number 2 here. Okay, just like mathematics, just like mathematics, you can do factorization. You can do factorization. When this is 2, this is 2, this is 2, you can cut away the number 2 here. Okay, when you cut the number 2, so you see the final answer, still H plus, still OH minus, still water. So that's it. So some student will say, sir, if let's say I forgot to simplify, I put a 2 here, I put a 2 here, I put a 2 here, I give this answer in the examination. If I give this answer, okay, in the exam, will I get any mark? Nope, you will get 0. Okay, they will penalize you, they will give you wrong if you didn't simplify the ionic equation. Okay, so the ionic equation must be simplified. Okay, so that's it. All right, so you see, at the end of the day, as long as this is a neutralization reaction between acid and alkali, this will be the ionic equation that you will get. All right, so that's it. This is what you need to know. Okay, when acid react with alkali, so this is the ionic equation that you will get. All right, so this is something very important. This is something very important, and this is quite popular in your SPM. Okay, so make sure everyone know how to get ionic equation for the reactions between acid and alkali. Okay, so I hope by now, okay, all of you should understand a few concepts already. You should know what is neutralization. Okay, so to have neutralization, you must have acid, and your final product must be salt and water only, nothing else. You only want salt and water and nothing else. Okay, so again, you must know what is chemical equation and what is ionic equation. So you must able to differentiate, you must able to tell the difference between chemical equation and ionic equation. Okay, so this is something that you have to be super careful, because ionic equation is something new for you. You never learn about it. Okay, so ionic equation is the equation that show us the ion. The ionic equation show us the ion, show us the charge. Okay, all right, so that is what we need to learn so far. Okay, so now we're going to move on with another important concept. Okay, this is the last concept that we will learn before we start with calculation. Before we start with calculation, this is the last concept that we must know, okay, that we must learn. So for neutralization reaction, we must know very important experiment, which is called titration. I repeat, okay, so for neutralization reaction, there is a very important experiment. Okay, and this experiment is called titration. Okay, this is very popular in SPM, so I'm gonna put a 5-star here. Okay, I'm gonna put a 5-star here so that you know this is a very important experiment that you must know. Okay, you must know. All right, okay, so we need to know, okay, what do we mean by titration? So titration is an experiment, and this experiment involves acid and alkali. So when you have acid and alkali mixed together, this experiment we call it as titration. Okay, how to do titration? Okay, so this is the apparatus setup, this is the experiment setup for titration, and you need to know this setup. Okay, you need to know this setup, because sometimes in SPM they will ask you to draw this diagram. I repeat, okay, this is the diagram for the experiment of titration. You must know how to draw this diagram. Okay, so let me show you one by one. So in this diagram, we have this long tube. This tube is called burette. Okay, this tube is called burette. Okay, burette is a very special apparatus. Burette is something very special. Okay, why? Because you see, normally if you have like measuring cylinder, or even you have conical flask, you can see some reading here. Okay, you can see some reading like this. Okay, you can see some reading on the glass. Normally you can see the small reading at the bottom, right, 0, and the big reading, let's say 100 on top. Same thing go to conical flask. The small reading 0 is at the bottom, the big reading, let's say 100, is on top. Okay, so normally you will see that, right? But burette is a little bit special. Burette is something very special. Burette, the small reading is on top. Okay, on top here, the small reading 0. The big reading is at the bottom. Okay, the big reading is at the bottom. Okay, so here, what is the final reading? No need to know. It depends. Some of the burette very long, so it can go up to 200. Some of the burette is very short only. Maybe the reading is 50. Okay, so you don't need to know what is the final reading. You just need to know that burette is very special because the small value is on top and the big value is at the bottom. Okay, so let me show you a real picture, a real diagram for burette. So this is the one. Okay, so this is a real diagram for burette like this. Okay, so you can see this is a burette. Okay, so on burette, okay, you can see 0 is on top, right? This is the smallest reading, 0 is on top, and the biggest reading is at the bottom. Okay, so this is the burette. So burette here, you can see this is something called a valve. Okay, valve means what? Okay, valve means opener lah. Valve means opener. Okay, so you can open here so that the liquid in the burette can go out here. Okay, the liquid can go out from here. Alright, so this is a burette. Okay, so when you open here, when you turn it open, so all the liquid from burette can go out. Okay, so and then the burette, the more liquid go out, the reading become bigger. You see, imagine this. Initially the liquid is until here. Okay, it's until here. So the reading is 0. So the initial reading, it is 0. Okay, let's say. So when some of the liquid you open and it go out, when the liquid go out, so when the liquid go out, you can see the level go down already. So the level now go down like this. Okay, right? So the level go down already. Okay, so here is empty already because the liquid here already go up. So now what is the final reading? You see the final reading is here. So the final reading is 10. Okay, so this is something very special because we know that normally, like in measuring cylinder, okay, the initial reading is this, is the small one, is 0. Then you add in the water inside, then go up, then the final reading is here, 50 for example. Yeah, so normally the final reading is higher than the initial reading, right? But for burette, everything terbalik. In burette, the initial reading is smaller. When the liquid go out, so the reading now become bigger and bigger. Okay, so this is something that you have to be careful. Burette is something very special. Burette is something very special. So let me show you another diagram. Okay, like this. You see, so this is the burette. Okay, so here you can open it so that the liquid in the burette can go out. Okay, so the more liquid go out, so here the reading will, here the liquid will go down. So the reading now become bigger and bigger. Okay, example, if the liquid is here, maybe it's 10. So now when the liquid go out already, so the reading is here, maybe is 35. Okay, so the reading become bigger. Okay, so in burette, the more liquid it go out, the reading here will become bigger. Okay, so this is something that you need to understand. Alright, so now in the burette, normally we put in acid. We put acid in the burette. Okay, so some student ask, sir, can we put alkali in the burette? Yes, but not for SPM. If you go for higher level like STPM, you go for matriculation, you go for A levels, then yes, you can put alkali in the burette. But for SPM, in SPM, inside the burette, we only put acid. We only put acid inside the burette. Okay, so this is acid. Is acid blue color? No, acid should be colorless. All the acid and all the alkali, they don't have color one. I repeat, guys, all acid, they don't have color, they are colorless. All alkalis, they don't have color, they are colorless. I just show you blue color so it looks more beautiful only. Okay, I just make it looks more beautiful. Okay, but in reality, acid and alkali, they are colorless. Okay, all right. So at the bottom here, you put a conical flask. Okay, at the bottom here, you put conical flask. So inside the conical flask, you put alkali. Okay, you put alkali. All right. So now you should know already. So acid, you put in the burette. Okay, so this is the burette. You put the acid. Alkali, you put in the conical flask. In the conical flask, you put alkali. You cannot terbalik. You cannot put alkali on top, acid at the bottom. Cannot. Not for SPM. SPM fixed already fixed. Acid must be on the burette, must be in the burette. Sorry, not on. It's in the burette. Alkali must be in the conical flask. Okay, so this is fixed already. So again, alkali don't have color. Alkali supposed to be colorless. Alkali should be colorless. I just purposely make it red color so it looks more beautiful. I just make it more beautiful only. But in reality, acid don't have color, alkali don't have color. Okay, all right. So then here you have something called indicator. Okay, so what is indicator? Okay, what is indicator? All right. Indicator is a special liquid. Indicator is not a solid. Indicator is not a gas. Indicator is a special liquid. Okay, so what is so special about indicator? Indicator will show you different colors in different condition. Okay, so when you put indicator in different condition, so the indicator will give you different color. Okay, what do we mean by different condition? Okay, what do we mean by different condition? There are three conditions you need to know. The first condition is acidic. The second condition is neutral. The third condition is alkaline. Okay, so which means what? If you put the indicator in acid, it will give you one color. If you put the indicator in neutral solution, so you will see another color. If you put the indicator in alkali, you will get another color. Okay, so that's it. Okay, so this is what's so special about indicator. Indicator can give us different color in the acid, in the alkali, and in neutral substance. Okay, so there are total 2 indicators that you need to know in SPM. In SPM, you only need to know, you only need to focus on 2 indicators. Okay, so the first indicator is called phenolphthalein. Okay, it's called phenolphthalein. So the name is very long, very weird, but you need to be able to spell. Okay, I can see many students always spell the name wrongly. Many students always spell the name wrongly. You must know how to write the name. Okay, so if you don't know how to write this, as usual, take a piece of paper, copy the name phenolphthalein. Okay, copy for few times. Okay, copy for few times. It will help you to memorize the name. Yeah, this one must know. You must know the name phenolphthalein. Another one is called methyl orange. Another indicator is called methyl orange. Some of the school teacher pronounce as methyl orange. It doesn't matter. Yeah, so you don't have oral test, so they won't ask you, oh, this is called methyl or methyl. It's okay as long as you know how to write it. methyl. Okay, A-N-G-E, okay? As long as you know how to write the name is okay already. So you want to pronounce as methyl orange or methyl orange, all good. It's okay, no problem, okay? So make sure you know these two indicators, and you need to know what are their colors in 3 conditions, okay? So phenolphthalein in acidic condition, it's colorless, okay? Phenolphthalein, if you put in a neutral solution, it is colorless also. But when you put phenolphthalein into alkali, you will see a pink color, okay? All right. So methyl orange, okay? Methyl orange, if you put in acid, so it will give you a red color. Methyl orange, if you put into a neutral solution, you will see a orange color. And if you put methyl orange in an alkali, so you will see a yellow color, okay? So this is what's so special about indicator. Indicator can give you different colors in different condition, okay? All right. So do you need to know all the colors here? Yes, you must know, okay? You must know the name of these two indicators, and you must know their colors in acidic condition, neutral condition, and also alkaline condition, okay? So same thing, if you're having difficulty in memorize, take a piece of paper, copy this table, yeah? Copy the name of indicator, copy the color, yeah? You can copy, okay, 1 to 3 times in a day, and then you copy, all right, maybe 5 days in a week, okay? So you do this normally for 2 to 3 weeks, you should be able to memorize the whole thing already, yeah? Just follow this method, okay? Take a piece of paper, copy this table, yeah? You copy this table 1 to 3 times in a day, okay? Or just 1 time will do lah. 1 times in a day. You copy 5 days in a week. Let's say Monday to Friday, then Saturday and also Sunday, no need lah, all right? You do it for 2 to 3 weeks. After 2 to 3 weeks, it will automatic go into your brain, okay? It will automatic go into your brain. You will automatic memorize this whole thing already, yeah? So this is something very important, yeah? All right. So make sure you know about this, huh? Make sure you know about this, okay? All right, so you see, so let me show you an example why indicator can do such a magic for you, okay? Why the indicator can actually do such a magic for us, okay? Let's say, you see, if I put methyl orange in acid, so remember what is the original color for acid, everyone? Colorless, remember all the acid, all the alkalis, they are colorless initially. Acid don't have color, alkali don't have color. When you put methyl orange in acid, what you will see? We know that if methyl orange in acidic form, you will see a red color, okay? So that's it. So if you add the methyl orange into the acid, so you can see now the color become red. That's it, okay? So same thing, if you put methyl orange into an alkali, if you put methyl orange into an alkali, what you will see? So methyl orange, if you put in alkaline condition, so you will get yellow, okay? So when we put methyl orange in alkali, so the solution now will become yellow, okay? All right, so indicator is very useful, okay? So imagine this, if you are given a solution and you don't know about this solution, so you are given an unknown solution, you don't know the solution is acidic, or you don't know the solution is alkali, okay? So you don't know the solution is acid or alkali, so you can just go to add in your indicator. Just add the indicator and go to see the color. That's it. Example, if you add in methyl orange, after you add methyl orange, this solution become red color. So now you know already, okay? When you see red color in the methyl orange, so you know already it is acidic. So now you know this solution, it is an acid, okay? So this is why we need to use indicator, okay? Indicator can tell us whether the solution is acidic, alkali or neutral by showing us different color. Okay, so indicator is very special liquid. They can give us different colors in different condition. Okay, so that's why we need to put indicator here. Okay, so why we need to put indicator in this experiment? Okay, why we need to put indicator in this titration experiment? Okay, because of this. Okay, all right. Okay, right here. Okay, without indicator, we will never know when to stop the titration. Okay, we never know when the titration process has already completed. You see, this is burette. In the burette, you have acid. So again, remember what is the color of acid? Acid is colorless. All the acid, they are colorless. This is your conical flask. In the conical flask, we have alkali. Again, guys, what is the color for alkali? Colorless. When acid react with alkali, the final product is salt and water, right? We learned this in your lesson number 2. Lesson number 2. Okay, when acid react with alkali, so, we will get salt and water. So salt is colorless, water also colorless. So what does it mean? Colorless acid mixed with colorless alkali produce colorless salt and water. Everything is colorless. Everything is colorless. So you will never know when the titration has already completed. Imagine this. You open the valve, you open the tap, you open the valve, acid go in. When the acid go in to mix with alkali, after 30 minutes, everything here is colorless. After 1 hour, still colorless. After 1 day, everything still colorless. So we never know when the titration is ended. Yeah, we never know when the titration already ends. Okay, because everything is colorless. So cannot. Okay, so that's why we need to use indicator. Okay, when we use indicator, different story. Okay, when we use indicator, this is the one. Okay, we will stop the titration once the indicator change in color. Okay, when you see indicator change color, you know the titration already completed. Example, you see, this is your alkali mixed with the indicator. So you can see this is the color lah. Okay, for example, let's say the color is purple lah. Okay, just assume only, this color is purple lah. Just assume only. Okay, and this is acid. So when you open the tap here, the acid will go in slowly. The acid will go in slowly. Tick 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 tick. Acid will go in slowly into the conical flask. So once the color here change, okay, when you see the color change, okay, like for example, purple become colorless, orange become red, red become yellow. Okay, whenever you see the color change, you know the titration already ends. Then you stop. Okay, you stop adding. Okay, you don't need to add liquid anymore already. Okay, once the color change, you stop. Okay, so let me show you like this. So let's say initially, okay, there is color inside. Okay, let's say initially there is color. So you open the tap here, you let the acid go in. Once the indicator here change color, okay, once the indicator change color, then you stop the tap. Don't add the liquid already because the titration already completed. Okay, so this is why we need indicator. Okay, when we see a color change, okay, when there is a color change on the indicator, it means that the titration process is already ended. Okay, this is why we need to add indicator, okay, in the titration experiment. Okay, so I want you all to imagine this. Without indicator, we will do the titration forever, because when you keep adding acid, you don't see any color change. Acid don't have color, They go into alkali, also don't have color. So when they react, the salt and water also don't have color. So without indicator, we will never know when we need to stop. When we need to stop. When the titration process already ended. Yeah. So that is what we need to understand. But once we add indicator, okay, once we add indicator, we know we will stop the titration once the indicator change color. Okay, when you see the color inside here change, then we stop. Okay, then we stop. All right. So if you put phenolphthalein, okay, if you use phenolphthalein, so the color will change from pink to colorless. Okay, why? Why you will change from pink to colorless? You see, initially, when we put phenolphthalein, just assume when we put phenolphthalein here, okay, so what is the original color? So when we add phenolphthalein in alkali, okay, so let's check. Phenolphthalein in alkaline condition, the color is pink. Okay, so you will see a pink color first. Okay, initially it's pink color because when phenolphthalein add with alkali is pink. Okay, so now what happened? Okay, so now when we open the tap here, when the acid go in, so the acid will react with the alkali. So when acid react with alkali, it will produce salt and water. Okay, when acid react with alkali, you produce salt and water. Salt and water is neutral. Salt and water, they are neutral. So now you can see the alkali now will become neutral. So in neutral condition, what is the color for the phenolphthalein? Is colorless. Okay, so when the acid go in, it will react with alkali, it will produce salt and water. Salt and water is neutral. So when the solution is neutral, the indicator will change color. Okay, you will change color. So what is the color? So in neutral condition, the phenolphthalein, it is colorless. So colorless. So that's why you can see the pink color will change to colorless. So when the pink color here become colorless, it means the titration is completed. The titration already done. So we stop adding the acid. Okay, we can stop adding the acid already. Okay, so that is what we need to know. Okay, so if you use phenolphthalein, so the color will change from pink to colorless. So you don't need to purposely memorize. You can just refer to this table. Okay, phenolphthalein, initially you put in alkali is pink. So after you add acid, the alkali now become neutral. So the pink now will become colorless. Okay, all right, so that's it. So this is the first part. Okay, all right, so now we're going to move on a little bit. All right, what about the next one? Okay, what about the next thing? All right. Okay, so if let's say we use methyl orange, if we use methyl orange as the indicator, so we will stop the titration when we see the color change from yellow to orange. When we see yellow change to orange, so we will stop the titration already. So you see, for example, okay, now we put the methyl orange indicator into the alkali. So initially, this conical flask has alkali and methyl orange. So we know that if the methyl orange in alkali, what is the color? Let's check. Methyl orange in alkaline form, it's yellow. So the original color here, it is yellow. Okay, so now when we open the tap here, open the tap, so the acid will go in step slowly, drop by drop. So now the acid will go in. Okay, so when the acid go in, the acid will react with alkali, right? When acid mix with alkali, they will react. So when acid react with alkali, so they will produce salt and water. So salt and water, they are neutral. So now neutral already. So in neutral condition, the methyl orange will change into orange color. So now you can see the color from yellow, it will change to orange. So when the yellow color change to orange, it means that all the alkali here already react with the acid, okay, to produce salt and water. Okay, when the final product is salt and water, it is neutral. When it become neutral, the color will change, okay, from the yellow to orange. So that's it. Okay, so this is the beauty of the indicator. Okay, when we see color change on the indicator, we know that the titration already comes to end. We know the titration is end once the indicator change color. That's why I say all of you must know what is the color of indicator in acidic form, in neutral form, and in alkaline form. Okay, that's it. So the last thing is this. Okay, why we need to put a white tile here? Why we need to put a white tile? Okay, because if you put something white at the bottom, so the light can reflect very well. Okay, there's more reflection. If you put a white tile, okay, the light will reflect. So if there is some light reflection, we can, this is your eyes, you can see the color change clearly. Okay, you can see the color change more clearly. So the white tile here only help us to see the color change more clearly. So if the question asks you, okay, why we use a white tile here? Why? So white tile will allow us to see color change. Okay, white tile can allow us to see the color change in the conical flask, okay, more clearly. Okay, so it's more easier for you to see the color change, okay, inside the conical flask, okay, if you put a white tile at the bottom. Okay, so that's it. So this is why we need to put a white tile. All right. Okay, so we are done with the experiment for titration. So now we are done with the experiment for titration. Okay, and again, among these two indicator, okay, among these two indicator that we learn, all right, so we learn two indicator, right? Okay, we learn about phenolphthalein and we learn about methyl orange. Okay, the more popular one is phenolphthalein. Okay, in SPM, out of 10 question in the titration, okay, about 8 question actually will ask about phenolphthalein. Okay, about 8 question they will ask about phenolphthalein. Okay, so phenolphthalein is more popular. Okay, it's more popular compared to the methyl orange. Okay, but you need to know both lah. You need to know both. You cannot say, all right, Mr. Martin say that phenolphthalein is more popular, so I only study phenolphthalein, so I don't want to study methyl orange. Cannot. Yeah, you need to know both. Okay, this one you need to know, this one you also need to know. All right, so that's everything you need to know about your titration process. Okay, so let me show you this picture. So you see, this is your titration process. So you put a clamp. So the clamp here you put your burette. So burette, inside here you put acid. Then at the bottom you have a conical flask. Conical flask you put alkali. Okay, so you put a towel at the bottom so that you can see color change, okay, more clearly. You put towel so that you can see the color change more easily. All right, so remember, okay, when we do titration, we need somebody to help us. This somebody is called indicator. Okay, why we need indicator? Because without indicator, everything is colorless. Without indicator, the acid is colorless, the alkali is colorless, the salt and water is colorless. So we cannot and we don't know when we should stop the titration. So when we put indicator, so we know we should stop the titration when the indicator change color. When you see the color here change, then you will stop the titration. Okay, so there are two important indicators that we need to know for your SPM. The first one is called phenolphthalein. Another one is called methyl orange. Okay, so this is everything you need to know for your titration process. Okay. Okay, so now we already learned about the concept of neutralization. Okay, we already learned about the Ionic equation for the neutralization, and we also learned about the titration. Okay, so titration is the experiment for the neutralization. Okay, so now we will move on and learn the last part for today's lesson. So we will learn the last thing, the last part for today's lesson, which is the calculation. So now we will learn the calculation that involve neutralization. Okay, so if we have a neutralization reaction, okay, how are we going to do the calculation process? Okay, so to do the calculation for neutralization process, so we will use this formula. Okay, so we will use the formula MA VA divide MBVB equal to A over B. So we need to know what it is. So MA, M stand for molarity, A stand for acid. So MA is the molarity of the acid. Okay, so the unit is mole per dm cube. So remember, in SPM, all the concentration, the unit is mole per dm cube. Okay, so VA, V is the symbol for volume, A is acid, so VA is volume of acid. So the unit for volume is cm cube, because I mentioned before, if we have a solution, the unit is cm cube. The volume for solution is cm cube. Okay, for gas is dm cube. So MB, the B stand for alkali. The B stand for alkali. A is acid, B is alkali. So MB is molarity of the alkali. Okay, VB is the volume of the alkali. Okay, so you can see here. So MB is the molarity of alkali. Then VB is the volume of alkali. Okay. Okay, what about here? Okay, so this A and B, what it is? Okay, so the A and B here is the A stand for ratio of acid, B stand for ratio of alkali. Yeah, so what do we mean by the ratio of acid and alkali? So if you want to get the ratio of the acid and alkali, we must write a balanced chemical equation. Okay, you must write the chemical equation. Okay, you must write a balanced chemical equation, then only you can get the ratio of the acid and the ratio of the alkali. Okay, for example, let me show you this. Okay, let me show you this one. So this is a chemical equation. This is the acid and this is alkali. Okay, when acid react with alkali, it produces salt and water. So when you write this balanced equation, then you can get the ratio of acid and the ratio of alkali. How to get the ratio of acid? Look at the number in front the acid. Look at the number in front the acid. So for sulfuric acid, in front here, we don't see any number. So if you don't see any number in front, it means 1. So the ratio of acid is 1. So A is 1. Okay, what about this? NaOH is alkali. So the number in front, alkali is 2. So the ratio of alkali is 2. Okay, so that's it. So the A is 1, the B is 2. Okay, so to get the ratio of acid and the ratio of alkali, please make sure you write a balanced chemical equation. Please make sure you write a balanced chemical equation. This is very important. Yeah, all right. So now I will show you the calculation, how to calculate the neutralization reaction question. How are we going to do the calculation regarding neutralization? So I will show you a few examples. Okay, so let's start with the first one. Okay, let's start with the first one. Okay, so this is the first example. So in this example, we are given a chemical equation. So we are given a chemical equation. So this chemical equation, they give us the information for the sodium hydroxide, and they tell us this is titrated with sulfuric acid. Yeah. So the question asks us, what is the volume of sulfuric acid that is needed to neutralize the sodium hydroxide solution? Okay. So when you see the word titrate, so you know already this is a titration. Titration is the experiment for neutralization. Okay, when you see the word titrate, you know that this is a titration experiment. Titration experiment is related to neutralization. Okay, so what you should do, okay, first of all, we must understand what we have and what we want. Whenever we want to do any calculation, you must understand what you have and what you want. Okay, so what we can do here is that, so we are given the sodium hydroxide and we are given the sulfuric acid. So for sodium hydroxide, we underline it here, and we are given 25 cm cube, which is the volume, and we are given 0.2 mole per dm cube, which is the molarity. So we have the volume and the molarity of the alkali. So for the sulfuric acid, we are given the molarity. We are given the molarity of sulfuric acid, which is this, and we want to know the volume of sulfuric acid. So the volume we don't know, so we put a question mark. Okay, so this is the information. So now what should we do? So we know that this is a neutralization reaction, right? Okay, how we know this is a neutralization reaction? Because we have acid react with alkali and we produce salt and water. Okay, so when we have acid and then it produce salt and water, we know this is neutralization. Okay, so neutralization, we will use the formula MAVA divide MBVB equal to A over B. Okay, so this is the formula that we will use for neutralization. So now we put in MA is the concentration of acid, which is this. This is the acid, the concentration is 0.1. So we put it 0.1 here. VA is the volume of acid. So this is acid, the volume we don't know. So we don't know the volume of acid, so we copy the VA. MB is the concentration of alkali. So this is alkali, the concentration is 0.2. So that's why we put 0.2 here. Okay, VB, V is volume, B is alkali, volume of alkali. So this is alkali, the volume is 25. So we put 25 over here. So lastly, A divided by B. This is the ratio. A is the ratio of acid. So look at the acid, the front number is 1. So A is 1. Alkali, the front number is 2. So B is 2. Okay, so now we know already A is 1, B is 2. Okay, so this is how we put all the number. So the next thing, we just key into calculator. We will get the final answer, VA equal to 25 cm cube. Okay, so this is how are we going to do the calculation. Okay, and don't to forget the final unit. The final unit is cm cube. Okay, because volume for solution must be in cm cube. Okay, so this is step by step how you do the calculation. Okay, so first of all, you must have a chemical equation. From the chemical equation, you list down the information. Okay, you list out the information, and then after that, you use a proper formula. Okay, many students use the formula M1V1 M2V2 because they can see here you have 2M and here there are 2V. So they use M1V1 M2V2. So you cannot use the formula M1V1 M2V2 for this reaction. Why? This is not a dilution. Okay, this is not a dilution. Dilution will happen when you add water to a solution. When you add water to a solution, that is dilution. So for this question, we add acid and alkali. So when acid and alkali mix together, it is not a dilution. It is neutralization. So for neutralization, use this formula put in all the numbers that you know, and then you solve the question, you solve the calculation. Okay, so that's it. Okay, so if you don't want to use this formula, MAVA MBVB equal to A over B, let's say in exam or in sudden you are panicked, you totally forgotten about this formula. So what you can do, you still can use the traditional method. So you can use another alternative method. Okay, how to do alternative method? Look at here. So this is the chemical equation. So now we know the volume and concentration of the alkali. We know the concentration of the acid, but we don't know the volume of the acid. So we can use the formula like this. Okay, so sodium hydroxide is a solution. Sodium hydroxide is alkali. Alkali is a solution. So when you want to do chemistry calculation, you can always start with the mole. Remember, in chemistry calculation, you can always start with the mole. So let's find the mole of the alkali. So to find the mole of alkali, alkali is a solution. To find the mole of solution, we can use the formula N equal to mV over 1000. Okay, we can use this formula to find the mole of alkali. So we put in the M, which is 0.2. We put in the V, which is 25. So then we will get the answer for the mole. So now from here, we know already the mole of alkali, it is 0.05 mole. So now we know the mole of alkali already, 0.005. So the next thing, we can find the mole of acid. We can find the mole of acid. So when you know the mole of one substance, you can find the mole of another substance by using ratio. You can use ratio. So what is the ratio here? So sodium hydroxide and the sulfuric acid, the ratio, look at the number in front. This is 2. And this one, no number, is 1, 2 to 1. See? So you can write this. Sodium hydroxide and sulfuric acid, the ratio is 2 to 1. So 2 to 1 means what? 2 to 1 means this. So this is 2, this is 1. So when 2 goes to 1, it becomes half, right? When 2 goes to 1, it becomes half. So the mole of sulfuric acid is half of 0.005. Okay? So you take 0.005 divided by 2. Okay? So from here, you know the mole for the acid is 0.0025. By doing ratio, now you know the mole of the sulfuric acid. Okay, once we get the mole of sulfuric acid, what is the next thing we can do? So we know sulfuric acid. Acid is a solution, right? All acid, they are solution. So solution, you can use the formula N equal to mV over 1000. For all solution, we can use the formula N equal to mV over 1000. Okay, so you put in the value. The N is the mole. So do we know the mole of acid? Yes, 0.0025. We can put the mole of acid here. The M is concentration. So the concentration of the acid is 0.1. So we can put 0.1 here. V is the volume. Volume of acid, we don't know. We don't know the volume of acid, so we copy the V. Yeah. So then, now you have all the numbers already. So after you have the numbers, you can use the calculator to calculate the V. The V is 25 cm3. So the answer must be the same as just now. Okay. So no matter you use this method or you use this method, also can. Both method also will get you the same answer. Alright. So make sure you know, okay, how to do it. Right, so let's go on with the example number 2. So let's move on to another example. So for example number 2, you can see here, based on the equation. So in this question, they give us a chemical equation as well. So they tell us that we have 20 cm3 of a monoprotic acid. So we are given an acid. The formula is HX. So this acid react completely with potassium hydroxide solution. Okay, so we have acid. It react with potassium hydroxide, which is alkali. When acid react with alkali, this is a neutralization reaction. Okay, when acid react with alkali, This is neutralization. Okay. So now the question asks, what is the molarity of the acid? So what should you do? We copy this equation here again. You put in all the information here. So the acid, the volume is 20. So here the volume is 20. So M is molarity. So we don't know about the molarity of acid, right? So we don't know the molarity of acid. So we put M equal to question mark. So the alkali, we know about the volume is 10. And we know the molarity is 0.1. So you see, for the alkali, volume is 10. Molarity is 0.1. So now we have everything already. So we know this is a neutralization reaction. Okay, when acid react with alkali, produce salt and water, this is a neutralization reaction. We can use the formula. Okay, we can use the formula. So put in all the things you know. Ma is the concentration of acid, which you don't know. So we copy the Ma here. Va is the volume of acid. So volume of acid is 20. So you put it here. Mb is the concentration of the alkali, which is this one, 0.1. Okay, you put it here. Vb is the volume of alkali. So this is the volume of alkali, which is 10. You put it here. So lastly, A divided by B, this is the ratio. To get the ratio, you must refer to chemical equation. So this is the chemical equation. The ratio of acid is 1. The ratio of alkali is 1. So the ratio is 1 to 1. Okay. So we do the calculation for the Ma. The final answer is 0.05. And make sure you know the unit. Make sure you put a proper unit. M is molarity. The final unit for molarity is mole per dm cube. Okay. So that is what you need to know. Alright. So if you don't want to use the formula MAVA over MBVB equal to A over B, you also can do the alternative method, okay, like just now. So this is the chemical equation, and these are the information that we know, okay, these are the information that we know. Alright, so we always can start with mole. In chemistry calculation, if you are so lost, if you don't know what you should do, the first thing, always try to get the mole first. Okay, always try to get the mole. Alright, so how to find the mole? Okay, so for the potassium hydroxide, you are given volume and molarity. Okay, so we know potassium hydroxide is alkali, and alkali is a solution. When you want to find the mole of solution, we use the formula N equal to mv over 1000. We use the formula N equal to mv over 1000. Put the M, put the V into the formula. Okay, so you will get the final mole to be 0.001. So this is the mole of your alkali, KOH. So now we already get the mole for alkali, okay, which is 0.001. Okay, so the next thing, we need to find the mole of acid, because your final calculation is the acid, right? Okay, you want to find the calculation for the acid. So now you need to get the mole of the acid. So how to get the mole of acid? We do the ratio. Okay, we can do the ratio. Okay, so what is the ratio? Okay, what is the ratio? So look at the ratio of the acid and the alkali. So in this case, the acid, the ratio is 1, alkali is 1. Okay, so the ratio of acid and alkali is 1 to 1. So 1 to 1 means the mole is the same. Okay, when you have 1 to 1 means the mole is the same. So if this is 0.01, the acid also 0.01. Okay, when the ratio is the same, the mole would be the same. So from here we know already the mole of the acid, HX. Okay, the acid is HX because they tell us. So the mole of the acid is 0.001. Okay, so now we already get the mole of the acid. So the next thing, what should we do? Okay, we know acid is a solution, right? All acids, all alkalis, they are solutions. So when we have solution, we can use the formula N equal to mv over 1000. This is the formula for us to do calculation for the solution. So the N is the mole. So we know the mole of the acid, right? Okay, the mole of acid is 0.001. So we put it here, 0.001. So the M is the molarity of acid, which we don't know. We don't know the molarity of acid, so we just copy the M. V is the volume for the acid. So you can check here. So the acid, the volume is 20. So we can put 20 at here. So then this whole thing key into calculator, you can get your M. So M, final answer is 0.05. Okay, so make sure you put the proper unit. M is molarity, the final unit is mole per dm cube. So you can see the answer 0.05 is exactly same as just now. So no matter which method you are using, the final answer must be the same. Yeah, so we have two methods to solve it. You can use MAVA over MBVB equal to A over B, or you can use N equal to MV over 1000 to find the mole of the alkali first. Then you use the ratio to find the mole of acid. Once you find the mole of acid, you use N equal to MV over 1000. You put in the mole value, you put in the volume, then only you find the molarity. Also can. Yeah, so it depends on which method that you feel more comfortable. Okay, it depends on which method you like to use in SPM. Both method also okay. Okay, so let's proceed. Let's continue with example number 3. Yeah? So for example number 3, so we are given this 50 cm cube of 0.75 mole per dm cube ammonia solution is titrated with nitric acid. Okay, so what is the volume of the nitric acid required to neutralize ammonia solution? Okay, so what should we do here? Okay, so before you do the calculation, you must have a chemical equation. Okay, so for example number 1 and example number 2, the chemical equation is given. Okay, in this question, they give us the chemical equation. In example number 2, they also give us the chemical equation. But please don't expect they will give you the chemical equation every time. I repeat, please don't expect they will give you the chemical equation every time. Yeah, so if they never give us the chemical equation, we must be able to write a balanced chemical equation on our own. We must know how to write a chemical equation ourselves if they never give us. Okay, so how to get this chemical equation? So you learned this previously in your lesson number 4. Okay, so you see, so let me show you. Ammonia, it's NH3. Ammonia would react with nitric acid. So nitric acid is HNO3. So when ammonia react with acid, what happens? So ammonia is an alkali, nitric acid is an acid. So when acid react with alkali, you should get salt and water. But I mentioned in your lesson number 4 before, I mentioned in lesson number 4, if the alkali is ammonia, the final product don't have water. Okay, if the alkali we use is ammonia, we don't get water in the end. Yeah, so make sure you know how to predict the formula for the salt. Okay, so how to get the salt formula? We need to list the charge. So ammonia, when it become the charge, it become NH4 plus ammonium. Hydrogen should be H plus. Okay, and then nitrate should be NO3 minus. Okay, but we don't write the H plus here. Why? The H plus already borrow. Okay, this nitric acid give the H plus to the ammonia, so the ammonia can become ammonium, because ammonia is NH3, which have no charge. For NH3 to become charged, it must become NH4 plus. So how the NH3 can become NH4 plus? They take the H plus from the acid. Okay, all the ammonia, they will take the H plus from the acid to become NH4 plus. So this H plus is already taken by the NH3 to become NH4 plus. So no more H plus here. Okay, so now we left 2 ion. So when you have 2 ion, you can get the salt. Okay, we can get the salt easily. So how to do it? So the charge is the same. We can cancel the charge, and this thing join together, NH4 NO3. So NH4 NO3 is the formula of the salt. Okay, then you need to double check to make sure the equation is balanced. Okay, right, so this is something very important. Many students, they don't know how to do the calculation is because they cannot write a balanced equation. They cannot write a balanced chemical equation. Okay, so make sure you know how to write chemical equation on your own. Okay, once you have the chemical equation, everything is easy. Okay, once you have the chemical equation, everything is easy. Okay, so now what we know, the ammonia, we know the volume and concentration. So we put the volume 50, concentration 0.75 at here. Okay, so the acid, what we know, acid, okay, the volume of the acid we don't know, but the concentration of the acid we know, right? We know the concentration of the acid, we don't know the volume of the acid. So what to do? This is the acid, volume we don't know, concentration is 1. Okay, so now you list down all the information. So after that, now we can do the calculation already. Okay, so ammonia is alkali, nitric acid is acid. When acid react with alkali, this is a neutralization reaction. Now when acid react with alkali, we know this is neutralization. So for neutralization, we can use formula MAVA divided by MBVB equal to A over B. Okay, so put in all the value. Okay, so for the MA, which is the molarity of acid, so molarity of acid is 1, so we put it here. VA is the volume of acid, so acid, the volume we don't know, so we just put it VA. MB is the molarity of alkali, so this is the ammonia is the alkali, molarity is 0.75, you put 0.75 here. VB is the volume of alkali, so this is alkali, volume is 50, so you put it here. So lastly, not to forget the ratio of acid and alkali. What is the ratio of acid? So nitric acid, the number in front is 1. Ammonia is the alkali, number in front is 1. So the acid and alkali, the ratio is 1 and 1. Just put it here. So put in your calculator, get your final answer VA. Okay, VA is 37.5. The final unit is cm cube because acid is a solution. Volume of solution should be in centimeter cube. So this is how we get the final answer. Okay, so that's it. We are done with this. Alright, so the next one. Okay, so now we move on to the next calculation. Okay, so if you don't want to use this method, also can. If you don't want to use MAVA, MBVB, also can. You can use this alternative method, okay, that we learned previously. Okay, so we start with a chemical equation. Okay, we start with the chemical equation first. So in chemical equation, you put in all the information. You put in all the information. Alright, so let's start with mole. Okay, because in chemistry calculation, if you are lost, if you don't know what to do, you can start with mole. So we can find the mole of ammonia. Okay, so ammonia, we are given volume and molarity. Okay, so when we given volume and molarity, what should we do? So ammonia is an alkali, so alkali is a solution. To find the mole of solution, we use N equal to MB over 1000. Okay, put in the M and V into the formula, okay, at here. So now you will get the calculation. The final answer is 0.0375. So this is the mole for your ammonia. So after you get the mole of ammonia, which is 0.0375, so now the next thing you want to find the mole of your acid. So how to find the mole of acid? You do ratio. So if you look at the ratio between the ammonia and the nitric acid, the ratio is 1 to 1. Okay, 1 to 1. Okay, so the ratio between ammonia and the nitric acid is 1 to 1. So 1 to 1 means they are the same. So the mole of acid should be the same as the ammonia. So ammonia is 0.0375. The acid should be 0.0375 as well. Okay, because the ratio is the same, the mole will be the same. So from this calculation, we were able to find the mole of your nitric acid already, which is 0.0375. Okay, once we get the mole of the nitric acid, what is the next thing we can do? So again, we know nitric acid, acid is a solution. All acid, they are solution. So for solution, we can use N equal to mv over 1000. So this is the formula for us to calculate the mole for the solution. So put in the value. So the mole of acid we know 0.0375. Molarity of the acid is given, which is 1. So we put the 1 here. V is the volume of the acid. Volume of acid we don't know, so we just copy the V here. So key into your calculator, we will get the same answer, 37.5. Okay, so this is how we do the calculation step by step. Okay, so let's continue. Okay, this is your example number 4. Okay, so for example number 4, so what is the next, what should we do here? Okay, so same thing. For this example, you are given 50 cm³ of the hydrochloric acid react with 50 cm³ of the calcium hydroxide solution. So we need to calculate the molarity of the acid. Okay, so same thing for this question, you are given the acid and you are given the alkali. Calcium hydroxide is one of the alkalis that we learned before. Okay, so when acid react with alkali, this is neutralization. So this question, they never give us the chemical equation, so we need to write ourselves. We must able to write ourselves the chemical equation between hydrochloric acid and calcium hydroxide. Okay, so if you write the equation, this is what you should get. Okay, you should get this chemical equation. Okay, so if you don't know how to get this chemical equation, please revise back your lesson number 2. Please make sure you revise back the lesson number 2, how to write the chemical equation, how to predict the salt. Okay, all right, so I will assume you know how to get this equation, but again, if you don't know how to do it, please do a revision. Revise back your Form 4 Chapter 6 lesson number 2. Okay, revise back how to write the chemical equation, okay, when acid react with alkali. All right, so that's it. So after you get the chemical equation, put in all the information. So you are given volume of the acid, you have the volume of the alkali, you have the molarity of the alkali. So you can see here, volume of acid, volume of alkali, molarity of alkali. So we want to find the molarity of acid. So the acid molarity is M. So we don't know the molarity, so we put a question mark. So again, how to do it? So when acid react with alkali, you know this is a neutralization reaction. So for neutralization reaction, we can use the formula MAVA MBVB equal to A over B. So put in everything, put in the value in the formula, all right? Then you were able to calculate the MA. So the MA, it is 0.5. Make sure you put the unit M is molarity, unit is mole per dm cube. Okay, so this is how we do. Not very hard. Okay, most importantly, most challenging part is how are you going to write and also balance the chemical equation. This is the most important thing, because without the balanced chemical equation, everything is wrong. Okay, if you don't know how to write a balanced chemical equation, you can't do any calculation here. Okay, all right. So again, if you don't want to use this MAVA, MBVB, you also can try your alternative method. Okay, so how to do the alternative method? So you write a balanced chemical equation first. You put all the information here. All right, then we start with the mole. Okay, we are given volume and molarity for the calcium hydroxide, so we can find the mole for calcium hydroxide. So calcium hydroxide is alkali. Alkali is a solution. To find mole of solution, we use N equal to mV over 1000. Put the M and V into this formula. You will get the mole 0.0125. So this is the mole of your alkali. Okay, so now we get the alkali 0.0125. So after you get the alkali, so the next thing you can find the mole of the acid. So how to find the mole of acid? We can do the ratio. Okay, ratio. Ratio of acid is 2. Ratio of alkali is 1. Okay, so you can copy it. Acid ratio with alkali is 2 to 1. So now, how are we going to do the calculation? So when we know the mole at here, we can find the mole of acid. So this is 1, this is 2. Mathematics, 1 become 2 means double. When 1 goes to 2 means double. Okay, so if this is 0.0125, when it come here, double. So 0.0125 double becomes 0.025. Okay, so this is mathematics. Okay, right, so make sure you know how to do the ratio calculation. Okay, so that's it. Okay, so when you do the mole of acid, so it's 0.0125 times 2. Okay, so now you get the mole of the acid already. So once you get the mole of acid, last thing, we put in the formula N equal to mV over 1000. Because acid is a solution, you can use this formula. So the mole of the acid 0.025, put it here. So M is molarity. So molarity of the acid, we don't know. So we just copy the M only. V is the volume of acid. Volume of acid is given 50. Okay, so you just need to do something like this. Okay, key in everything to your calculator. You are able to get MA to be 0.5. Okay, which is the final answer. So this is 0.5. The answer should be same as this method. If you use this method, the answer also 0.5. Okay, that's why I say no matter which method that you are using, the final answer must be the same. Okay, the final answer must be the same. All right, if the answer is wrong, if the answer is different, something wrong with your calculation. Okay, that's it. Okay, next one. So let me show you example number 5. Okay, so example number 5. So in an experiment, so we put the sulfuric acid to react with the ammonia. Okay, and then the initial burette reading is 10.50. What is the final burette reading at the end point? Okay, so what is end point? End point means the end of titration. Okay, just now I didn't explain what is end point, right? So now let's look back. What is end point? Okay, look back to here. Okay, so when the point where the indicator change color is known as end point. Okay, when you see the indicator change color, okay, it means the titration already ends, and that is called end point. Okay, end point means end of titration. End point means end of titration. The titration already completed. Yeah, the titration process is finished. That is called end point. Okay, so how are we going to do this? Okay, right? So it looks very complicated, right? No worry, we just do it step by step, okay? We just do it step by step, okay? So first of all, we need to start with writing a good chemical equation, okay? We write a good chemical equation first, We have sulfuric acid react with ammonia, okay? So we must know how to write the equation on our own. So if you write the equation, so this is what you are getting, okay? When ammonia react with sulfuric acid, you produce salt without the water, because I mentioned before, when acid react with alkali, you will get salt and water. But if the alkali is ammonia, the final product only have salt, don't have water, okay? So that's what you can see. When the acid react with ammonia, alkali, when the alkali is ammonia, the final product is salt. You don't have water at here, okay? So make sure you know how to write this chemical equation, okay? Same thing, if you cannot write this equation on your own, do your revision on your lesson number 4. Yeah, revise back lesson number 4 if you don't know how to write this balance equation on your own, okay? So after you have the equation, put in all the information. From here, the information. 0.2 is the molarity of the acid. That's why I put here, okay? So 20 is the volume of the alkali. 0.5 is the molarity of alkali. So you can see volume of alkali is 20. 0.5 is the molarity of the alkali. So what to do next? So same thing, when you have acid, when you have alkali, this is neutralization reaction. So for neutralization, use the formula, okay? So put in everything we know. So we know the molarity of acid, which is Ma. We know the volume of the alkali, which is Vb. We know the molarity of the alkali, which is Mb. So we know Ma, we know Vb, we know Mb. Yeah, so put in all the value and we will calculate to get the Va. Not to forget the ratio of A and B. A is the ratio of acid, so this is acid, the ratio is 1. B is the ratio of alkali, so ammonia is the alkali, the number in front, the ratio is 2, so the B is 2, okay? So put in everything to your calculator. Your final value should be 25, okay? So many students, after they get 25, they thought this is the final answer. They thought this is the final answer and they start to celebrate already. And then this is wrong. Why? This is not the final answer yet. Okay, this calculation is correct, but 25 is not the final answer, because 25 is referred to Va. Va is what? Volume of acid. Va is the volume of acid. But if you read the question carefully, they are not asking for the volume of acid, right? They're asking what is the final burette reading. What is the final burette reading at the end point? So what should we do? Okay, so this question is a K-BUT question. K-BUT, or we call HOTS. Okay, this is a critical thinking question. Okay, this question is not so straightforward, so you need to understand what they want. Okay, so how to get the burette reading? Okay, so let me show you the picture here. Okay, let me show you a picture. Okay, so remember, this thing is a burette. In the burette we have acid. Okay, so the initial burette reading, it is 10.5. How I know? Because the question tell us the initial burette reading is 10.5. So what is the final burette reading? So I said just now, burette is very special. The more you use the acid here, the value will become bigger, right? Remember just now I mentioned burette, the reading is upside down. Small value on top, big value at the bottom. The more acid we use, the bigger the value. Okay, the more acid we use, the bigger the volume. So if initially we have many acid, the volume is very small. Okay, if we use a lot of acid already, when the acid left a little bit, you can see the reading here is very big. Okay, so make sure everyone know this. I want you to imagine this. Okay, burette reading will become bigger when you use more and more acid. So the initial reading is 10.50. So after you use the acid, so now what is the final reading? So how much acid we use? Just now we calculate volume of acid that we use is 20, 25, right? Okay, just now we learned that the volume of acid VA is 25, which means what? We titrate 25 cm cube. 25 cm cube of the acid go into the conical flask. Okay, so we use 25 cm cube. So if this is 10.5, we use 25 cm cube already. What is the final value? So the final value will become bigger, right? It will become bigger. So 10.5 is the initial reading. You add with 25 that you use. So the final reading become 35.5. Okay, so this is the final reading on the burette, 35.5. Okay, so it's not really hard because you are still using the same formula to do the calculation. Okay, it's just that this is not the final answer. Okay, because 25 is only the volume of the acid. Okay, but the question want the final burette reading. So how to do that? The initial burette is 10.5, so we have 10.5 initial burette reading. So from the burette we use 25 cm cube of acid. So after we use 25 cm cube, the value will increase by 25. So from 10.5, the value increased by 25, you get 35.5. Okay, so here the most important concept you need to know is what? The more volume of acid you use, the burette reading will become bigger and bigger. If you don't understand this concept, you will find it very confusing. You'll be very blur. Okay, all right, so next one. Okay, so this is your example number 6. This is example number 6. Okay, all right, so the question say this. Okay, so the equation show you a neutralization reaction. So for this question, we have a neutralization reaction. So this question, they give us the chemical equation. Okay, and then these are the information. Okay, so the question asks, what is the total volume of the solution found in the conical flask at the end of titration? So what should we do? Again, step by step. We have the chemical equation. We put all the information here. All right, so we know the molarity of acid, which is here. We know the volume of alkali, sodium hydroxide, and we also know the molarity of the alkali. So the sodium hydroxide is the alkali. So sodium hydroxide is the alkali. We know the volume and we know the molarity. Okay, so we are not given the volume of the acid. Okay, so the next thing, so when acid react with alkali, so this is a neutralization reaction. So we use the formula MAVA MBVB equal to A over B. So put in all the information into the formula. Okay, after you put all the information into the formula, you get VA. VA, the final answer is 60. Okay, the final answer is 60. So this is not the final answer. Why? Right, 60 is VA. VA is volume of acid. VA stand for volume of acid. But if you read the question, they are not asking for the volume of acid, right? They are not asking the volume of acid. They ask us total volume of the solution in the conical flask. Okay, what is the total volume of the solution in the conical flask at the end of titration? Okay, when the titration is completed, what is the total volume inside the solution? So how to do it? Okay, so I want you to imagine this. Okay, so this is the titration process. Okay, so we know in titration, this burette is your acid, and this conical flask is your alkali, right? Okay, so the burette is here, and then the conical flask is here. So in the burette we have acid, and in the conical flask we have alkali. So they ask us, what is the final volume inside the conical flask? Okay, what is the final volume inside the conical flask? So this is not very hard. You just need to imagine. Initially in the conical flask we have alkali, right? Okay, in the conical flask we have alkali. Okay, so how much alkali in the conical flask? Okay, so the alkali sodium hydroxide we have 30. So we have 30 cm³ of alkali. Okay, so we have 30 cm³ of alkali here. So when we do the calculation, VA is 60. So VA is 60 means what? The volume of acid that we need to use in the titration is 60. Yeah? We need to use 60 cm³ of acid in the titration. So which means what? When you open the tap here, we need to add in 60 cm³ of the acid. We need to add 60 cm³ of the acid into the alkali to do the titration. Okay, so how we know 60? We calculate, right? Just now when we do the calculation, we get the VA is 60. So VA is 60 means we need to add 60 cm³ of acid into the alkali. So now what is the final volume here? Quite simple, right? 60 go in, add with 30, 60 plus 30 inside here. So the total volume should be 90. Okay, quite simple, right? Okay, we add in 60 cm³ of acid into the alkali. How much alkali we have? 30. So when 60 add into 30, now inside here, total volume become 90. Okay, so this is how they can ask a K-bar question. Okay, so we still get VA. We still use the formula MAVA divide MBVB equal to A over B. We still use the same formula, but this answer is not the final answer. Yeah, because the final answer, we need to know the total volume in the conical flask. So you need to know in the conical flask, initially you have alkali, then the burette you add in acid. So when the acid and alkali add together, then you will get the total volume that you want. Okay, so this is a very, very good question. This is a very good question, and this kind of question is where a lot of students always lose their mark. Okay, so make sure you know how to do it. All right, so now we will go on with the example number 7. So this is another K-bar question. This question actually combine everything that we learned previously. Yeah, this is a very good, very challenging question. Okay, all right. So that's why I call it a K-bar question. Okay, so what is it? So first of all, you can see, so we have a sodium hydroxide. So everyone remember, sodium hydroxide is an alkali. Yeah? Sodium hydroxide is our alkali. So the sodium hydroxide alkali is diluted to make 50 cm³ of sodium hydroxide solution. Then 50 cm³ of the diluted sodium hydroxide then is titrate with 1 mole per dm³ hydrochloric acid. So we need to calculate the volume of the acid that we need to use in the titration. So what make this question challenging? What make this question a little bit complicated is this question actually involve 2 steps. Okay, this is a tricky question that actually combine 2 concepts that we learned so far. The first concept is dilution, because you can see they take the sodium hydroxide, they dilute. They need to dilute the sodium hydroxide. Okay, so that is dilution. After they dilute the sodium hydroxide, then they mix the sodium hydroxide with the hydrochloric acid. Sodium hydroxide is alkali, hydrochloric acid is acid. When acid mixed with alkali, it is neutralization. Okay, so this question you have 2 concepts. Okay, dilution and neutralization. Just now, for all the example that we cover just now, there's only one concept, which is neutralization. But this question you have two, so you have to be careful. So we will do the first part, which is dilution. Let's do a dilution first. Okay, so I will draw a picture. Is it a must to draw the picture in your exam? No, you don't need to draw the picture, or don't need to draw a diagram if they never ask you to draw. But it's always good to do that, because if you can draw the picture, you can imagine, you know what is happening. Okay, so how to do the dilution? So initially we have 2 mole per dm cube and 10 cm cube of sodium hydroxide. So this is the sodium hydroxide. Initially the concentration is 2, the volume is 10. So now the sodium hydroxide undergo dilution. Okay, so dilute it. So after you do the dilution, so now the volume is 50. So after dilution, the volume become 50. Okay, so now we can calculate the final concentration after dilution. Yeah. So for dilution, we know that we can use the formula of M1V1 equal to M2V2. So when we have a dilution, we can use this formula to do calculation. So put in the value. M1 initial concentration is 2. V1 is the initial volume, which is 10. Okay. M2 is the final concentration after the dilution, which we don't know. V2 is the final volume after the dilution, which is 50. Okay, so if you put in everything here, you were able to get M2. Okay, the M2 you calculate is 0.4. So now we know already, after we do the dilution, the sodium hydroxide, now it become 0.4 mole per dm cube. Okay, so after we do the dilution, then we do another part, which is neutralization. Now we go to do neutralization. So to do neutralization, we need to write a chemical equation. So they didn't give us the chemical equation, so we need to know how to write it on our own. So we need to know how to write the balanced chemical equation. So we have sodium hydroxide, which is NaOH, react with hydrochloric acid, which is HCl. So let us write the chemical equation. So when the sodium hydroxide react with hydrochloric acid, you will get NaCl and water. Okay, so this chemical equation is not given. You need to know how to write it on your own. Okay, so when acid react with alkali, you get salt and water. So after you write the equation, so put in all the information. Okay, so now the sodium hydroxide, you know the volume is 50, so that's why you put the volume of sodium hydroxide 50 here. The concentration of sodium hydroxide, you cannot use 2. You cannot put 2. Why? This 2 is the concentration of sodium hydroxide before you do the dilution. Before you do the dilution, the concentration is 2. So remember, just now we already dilute the sodium hydroxide, and then the concentration now become 0.4. So now you have to be careful. The concentration of sodium hydroxide, it is 0.4 because we already dilute it. Okay, so the acid, they give you this. So the acid, the molarity is 1. Okay, and then the volume of acid, we don't know. We want to calculate the volume of acid. So you can see here. So this is the acid. Molarity is given to be 1. Volume of acid, we don't know. Alright. So we know this is a neutralization reaction. Okay, when this is a neutralization reaction, just use the formula. Put in all the value into the formula, and then you were able to calculate your VA. Okay, you were able to calculate the VA, volume of acid. So the volume of acid is 20 cm cube. Okay, so that's the final answer, because the question asked for volume of hydrochloric acid, which is VA. Volume of acid, which is VA. And by using the formula, we calculate, we get the answer. VA, it is 20 cm cube. Okay, so yeah, that is how we do the calculation. Alright, so this question is not very hard, but you need to understand how to combine two concepts together in a question. Okay, how to do dilution, M1 V1 M2 V2, how to do neutralization, MA/VA divide MB/VB equal to A divide by B. Okay, once you understand this concept, then you can do this question. Okay, this question, okay, more than 80% of students, they will make a mistake. Okay, when this question appear in SPM, more than 80% of students, they will make a mistake, or they cannot answer this question at all. They not even know how to do this question. Yeah, okay, all right, so we have two more examples to go. Okay, so this, just now we are doing example number 7, we have two more to go. Right, so now we want to move on to example number 8. Alright, so before we move on to example number 8, I want you to know this concept. Okay, sometimes the formula MAVA equal to A over B cannot be used, even the reaction it is neutralization. Okay, even it is a neutralization reaction. Okay, so not to say that every time when we have neutralization process, we always can use MAVA MBVB equal to A over B. No. Okay, sometimes even it is a neutralization, we cannot use the formula. Okay, MAVA MBVB equal to A over B. Okay, so let me show you by using example number 8 and also example number 9. Yeah? This will be the last two examples for today's lesson. Okay, all right, so let's look at it. Okay, so the question say this. Okay, a student dissolve hydrogen chloride gas HCl in water. Okay, so when we dissolve hydrogen chloride in water, you produce HCl, which is hydrochloric acid. Okay, so then you will have 500 cm cube of solution. Okay, so what happens is this, you put hydrogen chloride gas in the water. When the hydrogen chloride gas dissolve in the water, you will produce hydrochloric acid. How much hydrochloric acid you have? 500 cm cube. Okay, so the question wants you to calculate the molarity of the solution. You want to calculate the molarity of the solution if 6 grams of copper oxide is used to completely react with the solution form. Okay, so how to do this calculation? Okay, so first of all, we need to write a balanced chemical equation. Okay, we need to write a balanced chemical equation. Okay, so this is the chemical equation. So we have hydrochloric acid HCl react with copper oxide. Copper oxide, the formula is CuO. So when acid react with copper oxide, so what is copper oxide? Copper oxide, copper is a metal. So any metal ended with O, any metal ended with OH, it is a base, right? Okay, when we have any metal ended with O or OH, it is a base. So when acid react with base, so we will get a salt and we will get a water. Okay, all right, so now we put in all the information. So the acid, we know the volume is 500, which is here, right? This 500, it is hydrochloric acid. Okay, so we have 6 grams of copper oxide. So this is copper oxide. The mass is 6 grams. Okay, so how to do the calculation? Okay, so my first question, is this a neutralization reaction? Is this a neutralization reaction? Yes, this is a neutralization reaction. Why? When acid react with base or acid react with alkali, you produce salt and water. Okay, so when you have acid on one side and you have salt and water on the other side, you know this is neutralization. Okay, so yes, we know this is a neutralization reaction. Okay, So neutralization reaction, we can do the calculation by using the formula MAVA MBVB equal to A over B. So what is the problem? Okay, the problem is this. MA is the molarity of acid. So this is acid. Do we know the molarity? Nope, we don't know. Okay, so VA is the volume of acid. Do you know the volume of acid? Yes, it's 500. Okay, so we know the volume of acid. Yeah, MB is the molarity of the alkali. Do you know the molarity of alkali? No, you don't know. VB is the volume of alkali. Okay, volume of alkali. Do you know the volume of alkali? No, you don't know. Okay, A is the ratio of acid, which you have it. B is the ratio of alkali, you have it. Okay, so now what is the problem? The problem is this. If you look at this one, so we don't know MA, we don't know MB, we don't know VB. There are too many unknowns already. We have more than one unknowns. Okay, so when we have more than one unknown, we have three unknowns. There are three things that we don't know. Okay, we have three things that we don't know. So when we have three unknowns, there is no way you can use this formula. Okay, if you only can use this formula whenever you have only one unknown. Okay, when only you have one unknown, you only have one thing you don't know. Okay, then you can use the formula. But now you have total three unknown. Okay, three unknown, three things we don't know, so we cannot use this formula already. Okay, so that's why I say here there are more than one unknown, so this formula cannot be used. So since we cannot use this formula, so what should we do? Okay, so we copy the equation again, we put in all the information. Okay, so we go for the traditional method that we learned before. Okay, what do we mean by traditional method? Okay, so traditional method means this. In chemistry, when you have question and you don't know how to start with the calculation, if you given a calculation question, you not even know what you should do, how to start, always find the mole first. Okay, always find the mole first. So we know the mass of the copper oxide, so we can actually change the mass to mole. Okay, we can change the mass to mole. We learned this in your Form 4, Chapter 3. To change mass to mole, we need to divide by RAM. Okay, so this is what we do. Okay, so what is the mass? So the mass is 6 gram. Okay, so what about the RAM? So we need to find the RAM for the copper oxide. Okay, so how to find the RAM of copper oxide? So the question tells us for the copper, the RAM is 64. Oxygen, the RAM is 16. So that's what we do. Okay, so copper, the RAM it is 64. Oxygen, the RAM is 16. So if you add together, so the RAM is 80. So now we get the RAM for the copper oxide already. So we take 60 divide by RAM, which is 80. Okay, sorry, we take 6, not 60, sorry. We take 6 divide by 80. So we will get 0.075. Okay, so this is the mole. So this mole is referred to what? Copper oxide. Because when you are given the mass of the copper oxide, we find the mole, and the mole is copper oxide. So now we know already the mole of copper oxide is 0.075. Okay, so now once you found the mole of copper oxide, the next thing you should find the mole of your hydrochloric acid. So we do ratio. Okay, we do the ratio. So the ratio is what? So you look at here. So the acid, the ratio is 2. Copper oxide, the ratio it is 1. Okay, so the ratio is this. Okay, so the ratio of the acid and copper oxide is 2 to 1. So how to do the calculation? So copper oxide is 1, acid is 2. So 1 go to 2 is what? 1 go to 2 means double. So 0.075 double. Okay, so you take 0.075 times 2, you were able to get 0.15 mole, and this is the mole for your hydrochloric acid. Okay, by doing ratio, now you can get the mole for your hydrochloric acid. Okay, so once we get the mole of hydrochloric acid, what is the last thing we can do? Okay, so we know the acid is a solution. Acid is a solution. Solution, we can use N equal to mv over 1000. So put in all the value. The mole of the acid is 0.15. We put in here. M is the molarity of acid, which you don't know. V is the volume of acid, which is 500. So you put it here. So you key in the whole thing to calculator. You get the final answer. It is 0.3. Okay, unit mole per dm cube, because this is molarity. So from here you already get the final answer, okay, for the molarity. Okay, so what I'm trying to tell you is what this question, it is a neutralization. This is a neutralization reaction, but for this question we cannot use MA, VA, MB, VB equal to A over B, because there are too many unknown. Okay, we don't know MA, we don't know MB, we don't know VB. There are too many unknown, too many things that we don't know. So we cannot use the formula. Okay, so I hope that you know that. Okay, you don't think every time when it is neutralization, then you confirm can use MAVA, MB, VB equal to A over B. Not necessary. Depends on the question. Okay, so let's move on. So this will be the last example that we will discuss in today's lesson. Okay, so this is the last example that we will discuss. Okay, so the question say that you have a sample of zinc oxide was found to completely neutralize 100 cm cube, 0.4 mole per dm cube hydrochloric acid. Calculate the mass of the sample. So first of all, we need to write a chemical equation because it's not given. So we have zinc oxide, which is ZNO. We have hydrochloric acid is HCl. So we need to write the chemical equation first. So when hydrochloric acid react with zinc oxide, what happened? Hydrochloric acid is an acid. Zinc oxide, any metal ended with O, is a base. When acid react with base, you will get salt and water. Okay, so this is the chemical equation. Make sure you know how to write it on your own. And you must always make sure the chemical equation is balanced. After you write the chemical equation, you need to double check it is balanced. Okay, so this is a balanced chemical equation. Then you put all the information. So the information, now what we know, the acid, the volume is 100, concentration is 0.4. So you can see this is the acid, the volume is 100, concentration is 0.4. So the question asks for the mass of the sample. So what is the sample? So the sample is referred to zinc oxide. So the question says sample of zinc oxide. So which means what? We want to find the mass for the zinc oxide. Okay, we want to find the mass for the zinc oxide. So this is the zinc oxide. So we want to find the mass. So you put mass equal to question mark. You put mass equal to question mark. Okay, so that's what we do. All right. So now the next thing. So same thing, is this a neutralization reaction? This is a neutralization reaction because we have acid and then we produce salt and water. Okay, when we have acid and you produce salt and water, this is a neutralization. So although this is a neutralization reaction, but if you use the formula MAVA MBVB equal to A over B, you will find that the acid, you know the volume and concentration. So you know the volume for the and the concentration for acid, but for the alkali, you know nothing. Okay, you don't know the concentration of alkali, you don't know the volume of alkali. You can see here, they didn't give you volume or concentration of alkali. So since you have so many unknown, you have so many unknown. When you have more than one unknown, this formula cannot use. Tak boleh pakai, cannot use already, because when you have more than one unknown. Okay, so this formula cannot be used. Okay. So if you cannot use this formula, then we have to go back to the traditional method. So how to do the traditional method again? So this chemical equation copy, and all the information you copy. Yeah, so we copy the equation and we copy the information. Okay, so now what you should do, okay? So now the next thing, okay? So if you given a chemical equation, so and then you cannot use the formula MAVA, MBVB, okay? So then you have to go back to the traditional method. So how to do traditional method? So in chemistry, when you want to do traditional method, you must always find the mole first. Huh? I always mention this. When you given a chemistry calculation, you don't know what you should do, just go to find the mole first. Okay, so how to find the mole? So for the hydrochloric acid, you are given the volume and you are given molarity. So when you given volume and molarity, you can use the formula N equal to mv over 1000. So why we can use this formula? Because we know acid is a solution. So to find the mole of the solution, we always can use N equal to mv over 1000. So put in the m and v into the formula. Okay, put in the m and put in the v into this formula, and then you calculate, and then this is the final answer, 0.04. Okay, so this 0.04 is the mole of the acid. This is referred to the mole of your hydrochloric acid. Okay, this is the mole of your acid. Okay, so now we already get the mole of acid. So what should we do next? Okay, so in this question, they are asking us to find the mass of zinc oxide. So to find the mass of zinc oxide, we need to find the mole for zinc oxide first. How to find the mole of zinc oxide? We do ratio. Okay, so you can see hydrochloric acid and the zinc oxide, the ratio is 2 and 1. Okay, so hydrochloric acid and zinc oxide, the ratio is 2 and 1. So how to find the mole? Okay, so ratio here, 2 become 1, right? Okay, because we know the mole for we know the mole of hydrochloric acid, which is 0.04. So to find the mole of zinc oxide, 2 become 1. So when 2 go to 1, it means that the mole will be half. Okay, the mole will become half. So 0.04 half. So you divide by 2. Okay, 0.04 you divide by 2, you get 0.04 you divide by 2, you get 0.02. So this is the mole for the zinc oxide. Okay, by using the ratio, now we get the mole for zinc oxide already. So now how to finish the whole thing, how to finish the whole calculation. So now once you have the mole, but you want to find the mass, okay, we can use the concept we learned in your Form 4, Chapter 3. Mole can change to mass by multiply RAM. You can change mole to mass by multiply RAM. So, okay, so what is the mole for zinc oxide? We get it, 0.02, which is here. So now we need to get the RAM. So what is the RAM? This RAM is referred to zinc oxide, right? Okay, this RAM is zinc oxide. So zinc oxide, the RAM is given. Okay, zinc, the RAM is given to be 65. Oxygen, the RAM is given to be 16. Now, all these RAM, you don't need to memorize because the question, they will give you the numbers. Okay, all right. So now we know the zinc oxide, the RAM, we can calculate it. Zinc, it is 65. Oxygen, it is 16. So if you add together, it is 81. Okay, so you take the mole, which is 0.02, then you multiply by the RAM, which is 81. So key into your calculator, you get 1.62. You get 1.62. So not to forget the unit. What is the unit for mass? Gram. In chemistry, we use gram. In physics, we use kilogram. So by doing this, we already get the final answer, okay, which is 1.62 gram. Okay, so you can see This question also a neutralization reaction. This question also a neutralization reaction, but we cannot use the formula MAVA MBVB equal to AOB. Yeah. So depends. Sometimes even this is a neutralization reaction, but we cannot use the formula. Okay. So now let's make a final summary. So there are total 3 formula that we need to learn, that we need to use to calculate the solution. Okay, so these are the 3 formula. So make sure you know when and which formula to use. Okay, you use this formula whenever you want to do any calculation that is related to the mole for the solution. If the question asks you to get the mole of the solution, or if the question give you the mole for the solution, you can use this formula. You use this formula whenever the question is asking about dilution. When you want to dilute a solution, this is the formula to use. And this formula you can use whenever it is talking about neutralization. If the question is neutralization, then you can use this formula. Okay, so I hope you can fully understand all the calculation, all the formula that we learned so far. All right, so I think that's all for today's lesson. All right, so I'll see you in the next one. Yeah.